in this question, you're being asked to determine which of the three molecules is the most reactive electrophile for an SN2 reaction. So we have to remember, in an SN2 reaction, we have some sort of nucleophile attacking a carbon and kicking out a leaving group. So we want to look at these three molecules and determine what is the leaving group. And we can see that it is bromine on each molecule. Bromine is a good leaving group, so they're all the same in that respect. But if we look at these molecules, we can see this first one here is a methyl substrate, meaning it's a carbon with no other carbons attached to it. This substrate here is a primary substrate because there is one other carbon attached to the carbon bearing the leaving group. And this substrate here is a secondary substrate because this carbon, the electrophilic carbon, has two other carbons attached to it. So that is where these three molecules differ. And we have to remember that in an SN2 reaction, that nucleophile attacks from the opposite side of the leaving group, referred to as backside attack. Now, the more crowded that electrophilic carbon is, the carbon bearing the leaving group, the more crowded that is, the slower the SN2 reaction. So we can already see here that in this secondary substrate, the carbon, the electrophilic carbon, which I'm dotting in red, it has two other carbons attached to it. Those are going to block the ability of the nucleophile to get to that electrophilic carbon. That is going to make this SN2 reaction slower. So it's definitely not going to be this one here. If we look at this middle molecule, the primary substrate, that electrophilic carbon, which I'm dotting in red, it has one other carbon attached to it. And that is also going to block the electrophilic carbon from getting attacked by the nucleophile. Not as bad as a secondary substrate will. So this primary substrate is going to be faster to react than the secondary substrate, but it's not that one in this case. This molecule on the left, that is a methyl substrate. We call that a methyl substrate because it doesn't have any other carbons attached to it. So there's essentially nothing really blocking that electrophilic carbon, which I'm going to draw in red. There's nothing really blocking that from a nucleophile attacking it. So this molecule here is the one that will react fastest in an SN2 reaction because in this series, it has the least amount of steric hindrance.